So good morning, everyone.
Good morning.
All right, welcome back. Hope you had a good spring break. I think we finished off by taking a test right before spring break. So just to review the grades for the class average was an 80.7, so almost an 81. And we had 5 A's, 1 B, 10 C's, 1 D, 1 F. And these are the actual grades. So the highest grade in the class was a 105, and the lowest grade was a 52. Now, I also, when I graded these, if you check your grades, you should be able to click on your grade, and then you should be able to see the graded version of the test that I sent back to everybody. So did anybody see that? Yes?
I saw it.
Yes,
Okay.
sir, I did.
Okay, so if you have any trouble getting to that, you just go in through your grades, click on the test, and then there should be a file there that shows the markups that I put on your test. So overall, it was a good test. If you have any questions about your grade or anything else, or why I counted something wrong, just get with me during the office hours. I'll be happy to go over that with you. Okay, so it's been a while. I'll admit I can barely remember what we did last. But we were talking about 7.7 graphing tangent, cotangent, cosecant, and secant functions. And so all we had done is talked about how we graph cosecant, and realized that you just do the reciprocal of sine. So you graph a sine curve, and then you just draw these little U's, these little U-shaped, almost like parabolas. You have vertical asymptotes, and we did that for cosecant, and then we also did secant, and then we had just started doing tangent. And so that's where I want to start today. I want to continue by just starting fresh with how we graph a tangent function, and then we're going to get to cotangent. And then our plan today is to finish off 7.7, talk about 7.8, which is phase shift, hopefully get through that, and maybe even get pretty deep into 6.2, but we'll have to work fast. We're going to be playing catch up, because today we're really supposed to technically be starting 8.1, but we lost the winter storm week. We lost that week, so we'll do our best to try and catch up. All right, so anything before I begin? Good, we ready? Okay, so for tangent, if we're trying to graph the function f of x is tangent x, this is, again, I've already done this, but I just want to get our brains going again. To graph tangent, what we do is we write down what tangent is, and tangent is the sine function divided by the cosine function. And so when we look at this, there's certain values of x that we cannot plug into this function, because then we'll get division by 0. So if you look at the denominator, cosine x, you ask yourself, okay, so where is cosine equal to 0? And that would be a problem, right? Because you'd have division by 0. So we could just kind of look at the cosine graph real quick. We know that the basic cosine graph has these important points. It starts up here, kind of goes down like this, comes back up. So anywhere that we have an x-intercept, that would be here at pi over 2, here at 3 pi over 2, we should have a problem with the tangent function. So when we go to graph the tangent, I warmed my hand up, I guess. Okay, so we know that if we go to, let's say this is pi, we go to pi over 2, on the tangent function, we'll have a vertical asymptote here, because it'll be undefined. And we have another one over here at 3 pi over 2. And remember that the cosine function that I drew also goes backwards, right? It goes back like this and then comes this way. And we have an x-intercept also at negative pi over 2. This was at pi over 2. This was at 3 pi over 2. So if I wanted to continue this graph the other direction, at negative pi over 2, again, we would have another vertical asymptote. Are there any questions about where those are coming from? Okay, let's see. Okay, so that's where the vertical asymptotes are. The next question we could ask is, where are the x-intercepts of the tangent function? So where does this function hit the x-axis? And that would be whenever the sine function, which is the numerator, whenever that's 0, we get 0 over a number, and that would be 0. So we could then ask ourselves that, when is the sine function 0? Right, that's a question. And again, we just go to the graph of sine. Graph of sine looks like this, and that happens at 0 and at pi and at 2 pi. And then if we go backwards, it would happen at negative pi. So anywhere where we have x-intercepts on the sine function would correspond to x-intercepts on the tangent function. So I should have one here at pi. I should have another x-intercept here at 0. And then there's another one over here at negative pi, right? So that's what we know about the graph so far. And then what we could do to figure out what's happening in between the vertical asymptotes is we could actually just plug in some values. So I'm only going to do one value just because, again, we've done this before. I'm gonna look at the value right here. I'm going to look at pi over 4. So I'm going to ask myself, what happens if I plug pi over 4 into the tangent function? So maybe one of you can tell me what tangent of pi over 4 is. Think about the unit circle. Think about where pi over 4 is. Think about what tangent.
That would be 1, wouldn't it?
1. That's right. It'd be 1 because tangent is going to be the y coordinate, which is root 2 over 2, divided by the x coordinate, which is also root 2 over 2. And so if you divide those, you get 1. So we know at pi over 4, you get 1. And if we kept plugging in different values, okay, if we plug in different values between 0 and pi over 2, we could, maybe we could do pi over 3 or something like that, and get on our calculator and do it. What we would see is that the closer you get to pi over 2, the larger the numbers would get. And the closer you get to 0, the smaller the numbers would get. And so your graph would look like almost like the right side of a parabola. It would go up, and then you have the vertical asymptote in the way. And if you went the other direction, this to the left, you would see that you get the same numbers, but they'd be negative. So it'd be going like this. And so this right here is what the tangent function looks like. And in between each vertical asymptote, it just repeats itself. It just does the same thing. So all of those are supposed to look identical. I know they don't, I'm sorry. So the kind of thing you have to remember is that, when we're graphing sine and cosine, right, it's kind of like we have these 5 important points that we have to find, and then we draw our little frowns and smiles and put everything together. With a tangent function, all you really need to know is, where are the vertical asymptotes? Where are those? And then halfway in between those is where you'll have an x-intercept, always right in the middle of those. And then the right side will go up and the left side will go down. So you don't have like a 5-point method like we did with the sine and cosine. Questions on that? No? All right. Another thing we can ask is, what is the period of the tangent function? Remember, with sine and cosine, the period of the basic sine and cosine function is 2 pi. So it just repeats itself every 2 pi. Here, we just have to figure out, what's the distance between here and here. And hopefully you can tell that the distance between those two is pi. Okay, you can do it on the unit circle. If you just look at the unit circle, pi over 2 is straight up. Okay, that's pi over 2. And straight down would be negative pi over 2. And so that angle right here, that distance, that's pi. That's half of a rotation. So we know that the period of this is pi, and that goes for all of these. This is pi, and then this one, I didn't show the other vertical here, but we'd have a vertical here. That would also be pi.
Can the period of a tangent function graph change?
Yes, we can change the period of a tangent function just like we did with the sine and cosine. We can adjust it, yes. So do you remember on a sine function, if you had like sine, if you had a function f of x equals a sine, and then we use this omega x, right? Remember that? That's what we were doing. We put this number in front of x, and we said the period of the sine function would be equal to 2 pi over omega. That was a formula we had, right? With tangent, if we have a tangent function, we could have an a in front of it. See, a here was the amplitude, right? For sine, it told us how high and low the sine function went. For tangent, the a, all the a would do would be stretch the graph out. So it would make this like stretch out more narrow, or it would flatten it out to make it more like, let me do a different color. It would make it look more like that. So a adjusts that, but it's not called the amplitude. Okay, for tangent, it's not called amplitude. But if we put a omega in front of x like this, then the period here wouldn't be 2 pi over omega, it would be pi over omega. So if this is a 1, right, like the original tangent function, there's like a 1 in front of that x, then omega is 1, and pi over omega would be pi over 1, which is pi. Does that answer your question, Maddie? Okay, good. All right, so that's the tangent function. Let's look at cotangent. All right, so cotangent is very, very similar to tangent. And the reason it's similar is because cotangent, the definition, is the reciprocal of tangent. So instead of sine over cosine, it's cosine over sine. And I'm going to try and graph this one without going through as much work as I did last time. So can somebody tell me where I would have vertical asymptotes? Where would you have problems here?
Where sine of x equals 0.
Yeah, whenever sine of x is 0. And when is sine of x 0? At what places?
0, pi, and 2 pi.
0 at pi and at 2 pi is where sine is 0. So I know I should have vertical asymptotes here. Good. Also, we could go backwards, negative pi, negative 2 pi, right? I could keep going. All right, and then where should I have x-intercepts on the cotangent function?
In between, right?
In between. So it would be whenever cosine is 0, right? Whenever the numerator is 0. And cosine is 0 where? It is right in between, but what is that? Right here, right here, right here.
Pi over 2 and 3 pi over 2.
Pi over 2, 3 pi over 2, and negative pi over 2. So that's where we should have x-intercepts, right? For the cotangent function. And now you might think that it's going to do, well, let's pick a test point. Let me pick a point to just check it. Let's pick this point right here. This pi over 4. Okay, pi over 4. So if we plug in pi over 4 into this cotangent function, right, what would we get if we plug pi over 4 into this?
1.
1. So that means the graph would be here. Now, this one's a little harder. How about this? How about if we plug in a number that is a little bit bigger than pi over 2? So we just plugged in pi over 4, and we already know that cotangent would be 1 because this would be the x coordinate divided by the y, which gives you 1. But if I plug this value in, 3 pi over 4, that's right here. That's negative root 2 over 2, and then positive root 2 over 2. So if I do cosine over sine, that's the x divided by the y, I get -1, right? So now this graph over here goes down. So do y'all see it's just, it seems like it's going to be just like tangent, but flipped over. So instead of going like tangent, right? Tangent went kind of, if you, oops, I lost it. Where is it? Tangent, if you were reading it like a book from left to right, tangent went up, right? It went from down and it started going up. But when you do the cotangent, it's the opposite. It starts up and it comes down. And every single one of these periods would look the same. Like that. What is the period of the cotangent function? How often do these things occur? What's the distance between here and here? This
Pi.
one's a little more obvious. What is it?
Pi.
Pi. It's just from here, like from 0 to pi, so that would just be pi. And then from pi to 2 pi, that would be pi. And then from 0 to -pi, that distance would be pi. So tangent and cotangent have the same period, right? They have the same period. The difference between tangent and cotangent is where the x-intercepts occur, right? They don't occur in the same place. And one of them goes, down to up and the other one goes up to down. So let me show you these in a different picture here. Let me save that. We'll come back to that. You know what? I think I'll just start a new one. Oops. Oh, no. No, there we go. So if I graph tangent x, there it is. Let me get my graph here to be pi over 4. Okay, there's tangent x. Let me zoom in here. So for tangent, you can see it just repeats itself, but it's happening here between -pi/2 and pi/2. Let's see if this will work. Oh, oops. Between -pi/2, we have vertical asymptote, and pi/2, we have vertical asymptote here. Now, if I graph cotangent x, see, they're flipped over, but they have different x-intercepts. Please make sure you understand that. The x-intercept of the tangent function is not the same as the x-intercept of the cotangent. So those are the main differences. Different x-intercepts and different shape as far as up and down and down and up. Any questions there? And Maddie, the question you asked earlier about tangent, does it have a period? Does it have something similar? It'd be the same exact thing. If you want to know the period of cotangent, you would take pi and divide it by the number in front of x. So pi over omega. All right, we move on. So that's it. That's it for the cotangent function. Let's see, maybe we can, I think that's enough. I think when we do the next section, we can put this all together, okay? So we are going to start phase shifts. Oh, by the way, the homework assignments, I pushed all the deadlines out till I think like the 22nd. Just like the ones that like this one and the next few are just pushed out to like the 22nd or 24th of March, just to give us time to like get caught up and figure out where we are, okay? All right, so the next section, 7.8, has to do with this concept called phase shift, which we have not done, we have not talked about, and we are not going to be doing this part. So I know it'll curve fitting. We're not going to be doing that. We're just going to be talking about phase shift. So this is kind of like the final version of graphing sine and cosine. All right, this is like we've started to build this thing up. We've already studied what it meant. Well, let me write it down on the side. We've already studied how to graph this. Okay, check. We should know how to graph that. If we're given a number in front of the sign, it tells us the amplitude. If it's negative, then we flip it over. The omega gives us the period, right? But now we have these two new elements that we're going to add here. next to the omega x, we're going to subtract a number. Now, this is the Greek letter. It's pronounced different ways depending on who you ask. Phi, you might hear people call this phi. You might hear people call this phi. Okay. I use both. Okay, because it's, you know, I don't think you're wrong either way. But this Greek letter phi is some number we're going to subtract inside the parentheses. Okay, and that has an impact on the shape of the graph. And then at the back side of the function, we're going to add a number called b. All right, this is the ultimate kind of like final version of what a sine function could look like. And this phi here is going to have an impact on the graph in a very unusual way. Remember that the omega is kind of condenses, it makes the period, it changes the period, right? So you have more sine waves happening in a short amount of space, or it stretches it out. But this right here does something else. So let's look at what it does. Where is it? This one right here. So this might be hard to understand, but let me see if this makes sense. So this A1 is like the A in front of the sine function. This W1 is the omega. Here's X, and then minus, I put P1 for the phi, all right? So I'm gonna subtract a phi, and then I'm gonna add B, I'm gonna call it B1. And I'm using B1 and phi1 and because when I do cosine, I have to call it something else. So I have it called P2 and B2 and so on and so forth. So let's see what happens. First of all, we know what happens if we adjust A, right? A is going to change our amplitude, right? That's going to change the peaks and valleys. I'll take it back to 1 because that's what we're used to, maybe. There we go. We know that if we change omega, it's going to either compress everything down, have more waves, or it's going to stretch it out, right? That's omega. I'll put it back to 1, maybe. There we go. Okay, so that's our standard sine curve. Let's start with the B on the outside. So if we take a number B and we add it, then what does it do? Well, it just moves the whole graph up. So notice that's not changing the amplitude. That's just a vertical shift of the graph, right? A vertical shift up. If we add a number, if we subtract a number like minus something, then it'll move the whole graph down, right? Does that make sense? I mean, that's kind of what happened in college algebra. If we add a number on the outside of the function, it's just a vertical shift. Now, the phi, let me get back to B is 0, so leave it back to its normal shape here. Now, here comes the phi. All right, so what you have to be careful with is in the formula, there's a minus here. And you might remember this from college algebra. This has to do with horizontal shifting. When you want to move something, when you want to move a graph horizontally, it behaves opposite of what you would think. If you subtract a number inside the function, it moves it right. And if you add a number, it moves it left, which is opposite of the way vertical shifts work. Vertical shifts, if you add a number, it goes up. If you subtract a number, it goes down. But here, when we subtract a number, we go to the right, and add, we go left. So let me just show you. I'm going to subtract a number right now. I'm actually subtracting pi over 6. You can't tell there. Oh, you know what? Let me change this to just step. Let me make it 1, and that way it's a little easier. Okay, there we go. Okay, so if I take this and I subtract the number 1, look what happens to the graph. It moved to the right. You see that? If I subtract 2, it's going to keep moving to the right, keep moving to the right. And now if I do the opposite, which would be instead of subtracting a number, I subtract a negative number. So notice that this is -1. If I subtract -1, that's the same as adding 1. And so the whole graph went to the left 1 instead. And so that's what we call a phase shift. Okay, a left and right shift of the sine function is called a phase shift. Does that
So
all make sense?
a
Yes, go
phase
ahead.
shift is just another term for a horizontal shift.
That is right. A phase shift is just a horizontal shift, but when you're talking about sine functions and cosine functions, we call it a phase shift. Yep, but it's just a horizontal shift from college algebra. That's all it is. All right, so here's kind of a new summary. If we're given a sine curve, A sine of omega x minus phi plus some b. We already know that the amplitude is the absolute value of a. We already know that the period, which we call capital T, is 2 pi over omega. So we take that number, we divide it into 2 pi, that gives us our period. And now here's the new thing. The phase shift, which tells you your left and right shift, is going to be phi over omega. Okay, so you take this number and you divide it by this number. All right, now it'll be a shift to the left if that number is negative. Now, listen to what I'm saying there and what they're saying here. It'll shift to the left if this number here is negative. And that means if that's a negative number, then when you subtract a negative, this will actually look like a positive number. So that's where you have to be careful. Now, if that phi is greater than 0, then it will be a shift to the right. And so think about this. If this number is positive, then you're subtracting a positive number. It would be a minus sign there. Okay, so that's what I was saying. You just have to be careful with that sign. All right, so let's try and do one of these and see if we can kind of, these are a set of steps. I don't feel like going through all the steps right now. What I want to do is just do an example. Okay, so I'm going to start with an example here and see if we can't figure this out. Okay, so our goal here is to graph this, all right? So let's identify some things first. We know that the amplitude of this is 4, right? Because there's a 4 in front of it. All right, we know that the period, which we call t, okay, just remember this is the period we're talking about here. The period of this will be 2 pi over omega, which for us is 2 pi over 2, which tells us that we have a period of pi. Everyone agree? Now, what we would normally do, and here's where things get different, all right? This is where things are going to start to get confusing. What we would normally do at this point is we would draw a graph. Don't draw this yet. I'm just showing you what we would normally do. We would say, okay, I know the sine function starts at 0, and here the period is pi, so I'm going to stop at pi, and then I'm going to start cutting this in half and go pi over 2, and then cut that in half. That'll be pi over 4, and then cut that in half. So find the point in between these two, so that would be 3 pi over 4. I'm not showing the work, but that's what we'd normally do. And then we would say, okay, it's an amplitude of 4, so here and here. And then we would say it's a normal sine curve, so it should start here, have x-intercepts at the ends and in the middle, and then we would draw it like this, right? That would be the normal procedure. But that's not what we're going to do at all now, all right? And this is where you have to kind of, in some way, erase what we did before, and that's what I hate about doing this section is we have kind of a brand new method to do this, all right? So here's what we're going to do. Because we have this in here now, right? We know that our phi here is equal to, maybe you can tell me. What's phi? Is it negative pi or pi?
Pi.
It's pi, right? It's because in the formula, it was omega x minus phi. So phi for us is pi, right? Okay, so let's just remember that. Now, can you tell me what the phase shift is? Let me go back up to the formula here. The phase shift, I'm just going to call it PS. Phase shift should be phi over omega, right?
So it's pi over 2.
Yeah, so phase shift should be pi. I'm sorry, phi, which is pi. Oh, let me write the formula. Phi over omega, right? That's the formula for the phase shift, phi over omega. And for us, phi is pi, all right? And what was omega?
2.
2, right? The number in front of x. So this is going to be, oh, I don't know what, 2, pi over 2. So what that tells you is that this thing has been, this is a sine curve that's been shifted, what, to the left or to the right?
To the left.
So do we have a minus here?
No, it's positive pi, so it'd be to the right.
Yeah, so this is where you have to be careful. When you see that minus in there, and we see that the phi is a positive number, right? This is a positive number. If that's positive, then this is going to be a right shift. I'll show you an example where we get a left shift, and hopefully it'll make more sense. Now, okay, you ready? This is just me identifying all the different pieces. We have amplitude, we have period, we know the phase shift, we got everything in order, right? Now what we need to do is draw the graph. So here's what I want to do. We are going to figure out right now where this sine curve starts and stops. One period. Where is the starting of the period and where is the ending of the period? And to do that, we're going to find the start and the stop of one period. All right, that's what we're about to do. And to do this, here's what you do. You take the argument of the sine function. That's called the argument. Oh, can't spell. The argument of the function. And what you do is you set up two equations. You first ask yourself, when is this equal to 0? And then you ask yourself, when is this equal to 2 pi? So remember, a normal sine curve starts at 0 and ends at 2 pi, right? 0 and 2 pi are the two endpoints of a normal sine curve. What we're doing is we're trying to figure out when this in here will equal 0 and when it will equal 2 pi. You will always use 0 and 2 pi, all right, when you're setting up this starting and stopping. And then what we're going to do is solve for x. Okay, so when I solve this for x, I add pi to both sides. So I get 2x equals pi. And then I divide both sides by 2. And I get pi over 2. Okay. Now I go to the other one and I do the same thing. I add pi. So now we have 2x equals 2 pi plus pi is 3 pi. And I divide by 2, I get 3 pi over 2. Like that. And that should correspond to my starting and stopping points. So now it's time to graph. So let's see, pi over 2, I'm just going to put it here. And 3 pi over 2, I'm just going to put it here. Those are the two endpoints of this sine curve. And now what I have to do is what we did before, is I have to do like the 5 points. So I need to figure out the point right in between those. Then I have to figure out the point in between here and in between here. So let me start with the point in the middle. And remember, I told y'all how to do that, right? You take these two, you add them, and you divide by 2. So you take their average. So if you add the top, you get 4 pi over 2. But then you're going to divide that by 2. So that's 2 pi over 2, and that just gives you pi.
I have a quick question.
Yes.
When finding the start and stop of a period, does that only work for sine and cosine, or will it also work for tangent and cotangent?
Good question. It'll work for sine and cosine. When you do tangent and cotangent, you won't be setting it equal to 0 and 2 pi. For tangent, you'll be setting it equal to negative pi over 2 and pi over 2. And for cotangent, you'll be setting it equal to 0 and pi, because remember, that's where they started and stopped. That's where the vertical asymptotes were. We will do that. We're about to do it in some other examples. Good question, though. This is only for sine and cosine. All right, is everyone okay that I got this here? It's all right? Okay, now, then I could do the same thing here. I'll do one more of these, and then I'll just leave it to you to get the other one. I'm going to try and find the one in between those. So I take pi over 2 plus pi, and I divide that by 2. So that's pi over 2. I have to get a common denominator, plus 2 pi over 2 all over 2. This is 3 pi over 2 over 2. And that should come out to be, does anyone have that? 3 pi over 2 times, I'm going to look at that 2 on the bottom as 2 over 1 and then flip it. So 3 pi over 4. Okay, 3 pi over 4. Okay, this one I'm not going to show is 5 pi over 4. All right, any questions? All right, we should have an amplitude of 4, and it's a sine curve that starts here. So it should start, I'm going to do it in red. It should start at pi over 2, end at 3 pi over 2. We know that halfway in between, we should have another x-intercept. We should have an amplitude of 4. So it should go up 4, let's see, down 4. It was a positive 4, so I'm not going to flip it over. So I'm just going to draw my sine curve. So I should go up here, then over here I should go down, and then I draw kind of like a frown, and then I draw a smile, and there we go. Any questions?
If you had to have a vertical shift in there, would you do that before you find the horizontal or after?
If you what?
If you have a vertical shift, would you do that before the horizontal?
Okay, yeah, so if you have a vertical shift, then you would do it at this point. This is where
Okay.
you'd move it up or you'd move it down.
Okay.
Okay,
Thank you.
yep, we're going to do one. If I can find it, here we go. Okay, so let's do one that has a vertical shift. Let's do a cosine one. How about this one? This one looks good. Okay, so here, let me put it down here. And what I'm going to do is right now, I'm going to give you a minute. I want you to try and find the amplitude, the period, and the phase shift. And then see if you can find the start and the ends for this, okay? And I'll just give you a few minutes to try that. Let me see, it's 9:39. Let me give you about 5 minutes just to see if you can come up with that. And if you see if you can do the whole thing on your own also. But I just want to see how you do on your own with this first. All right, so how's it going here? We're getting somewhere with it?
I got stuck when it came to time to graph it.
Yeah. Okay, amplitude is 2, right? That comes from the number in front. The period, which we call t, is going to be 2 pi over 2 pi here, which is 1. And then the phase shift. Okay, so here's the tricky part. What is phi here? Can someone tell me what phi is?
4.
4. So look at the form. Look at this here. 2 pi x omega in front of x, and then we have plus 4, right? But in the general formula for this, it's always got to be omega x minus phi, right? So you always have to try and look at that as a minus. So you have to see that this is actually minus -4. Right? That's what plus means, minus -4.
Then it
So
would be -4.
it'd be -4, exactly. Okay, and so your phase shift will be -4 over, right, omega, which is
2 pi.
2 pi. Maybe I should write that formula down. Pi over omega, which is -4 over 2 pi. And you can reduce the 2 on the bottom, top and bottom, so you get -2 over pi. That makes sense, everyone? Is this going to be a shift to the left or to the right?
To the
To a
left.
left.
To the left. And the way I do that is I look at this sign. If this is plus, then I'm going to go opposite of what I think. So I'm going to go left. So this is a shift to the left.
You don't go based off of the sign of the phase shift.
What's that?
The phase shift is
Negative.
simplified to -2 over pi. You wouldn't just go off of the
Yes.
sign of that.
You could, yes, you could do it that way also. I'm just saying the way I do it is when I look at the original function, if I see a plus, I know it's going to the left. If I see a minus, I know it's going to the right. That's the way I look at it. But if you look at the actual phase shift, it says negative, so you think left. Okay, so now this is the part where you have to figure out where you start and stop, right? So to do this, you're going to set up 2 equations. We're going to go 2 pi x plus 4, we're going to set it equal to 0. And then the other one we're going to do is 2 pi x plus 4 equals 2 pi. And again, we'll always use 0 and 2 pi when we're talking about sine or cosine. And now you just solve this equation. So I'm going to subtract 4 on both sides. That'll give me 2 pi x equals -4. Excuse me. And then I will divide by 2 pi. So -4 over 2 pi, which again gives you -2 over pi. The other one, we subtract 4. So this is going to be a little weird. We're going to have 2 pi x equals 2 pi minus 4. Now, I'm not going to do that on my calculator. I'm just going to leave it like that. And then what I'm going to do is divide everything by 2 pi. You with me?
And just to confirm, you always set the start and end equations to 0 and 2 pi.
For sine and cosine, yes. Mhm.
Does that also work for the reciprocals?
For reciprocal, what do you mean?
For cosecant and secant?
Okay, yes, if we're doing cosecant and secant, those 2 functions, we would do the same thing, because remember to graph those, we basically turn it into a sine or cosine, and then we do everything, and then we just do the little u's. So yeah, it would work for those also.
Okay.
0 and 2 pi. All right, so now what we'll do is, I mean, we could go with this, but I'm going to rewrite this as 2 pi over 2 pi minus 4 over 2 pi. I'm going to split it into two fractions because I have one denominator. And I'm only doing that because 2 pi over 2 pi is 1. And then I have minus, if I reduce that, I get 2 pi over pi. I mean, sorry, 2 over pi. That's the other one. So now let's try and graph. Okay. So we have the first point here is negative 2 over pi, right? That's this one. Is everyone comfortable with the idea that that one is to the left of this one? Because they both have minus 2 over pi, right? This one has 1 added to it. So this should be a little bit bigger than this one. So I'm going to put negative 2 over pi here. And then just anywhere to the right, I'm going to put 1 minus 2 over pi. And then what I need to do is find halfway, and then halfway between that and halfway between that. And again, I'm not going to use my calculator. I'm not going to do decimals here. I'm going to do everything by hand. So let's try and find that middle point. So I'm going to take the 2, negative 2 over pi. I'm going to add to it the other one, 1 minus 2 over pi, and then I'll divide the whole thing by 2. This is going to be weird, all right? So when you put the numerator together, you should get 1 minus 4 over pi. So the way I did that is these two, when I put them together, they have the same denominator, right? They both have pi on the bottom, so I just add up their numerator. So negative 2 and negative 2 is negative 4. So I just put them there like that, and then I divide that whole thing by 2. So when I divide by 2, it's the same as multiplying. It's the same as taking the numerator and multiplying it by the reciprocal of 2, which is a half. And then I'm just going to distribute this through. So we should get 1/2 times 1, which is a half. And then when I do the next one, the 2's are going to reduce again. And I get this. 1/2, and then minus 2 over pi again. That should be this middle number. Are there any questions there? I know it's weird, but this is like as hard as it gets, all right, in terms of trying to figure out these middle points. This is about as complicated as it's going to get. Now, I'm not going to show you the other ones. I'm just going to put what they are. This one would be 1/4 minus 2 over pi, and this one would be 3/4 minus 2 over pi. And what am I drawing here? I forgot. See, I'm drawing a cosine function with an amplitude of 2. So if I go up to 2 and down to negative 2, a cosine function, remember, it has x-intercepts that occur at the quarter mark and the 3/4 mark. And then we have a high point at the beginning, a high point at the end, and a low point in the middle. And then I'm going to just draw it. So I have like a little frown that turns into a smile. It continues, and then it becomes a frown again.
Sir, since there's a +4 at the very end, don't the points move up 4?
Yeah, so this is like this is the graph that now, if we have any sort of vertical shift, we now need to move it, right? So we go up and we look at our +4 right here, this +4, right? That takes every point and moves it up 4. So this is not our final picture. We've got to move it all up 4. So I need to extend my graph further up. So this point right here was at 2, right? It now needs to go up to 6. So let's say that's 4, let's say that's 6. So now that point's going to move up to here. This point that used to be at 0 is going to move up to 4. How about this point that was at -2? Where does it move?
Two.
It goes up to 2. This point goes up to 4. And then this point goes up to 6. And then you just basically have to draw the same thing. And that in green is the final picture. What do y'all think? It's a little weird, right? Especially when these numbers are strange like this.
Yeah, that's what I didn't like about the problem.
Yeah. Okay, let me see if I can actually do this. This was a cosine function, right? So let me graph it. We had our A was 4. No, it was 2, sorry. 2. Our omega was what, 2 pi? And let's see, what was our B was 4. And our phase shift thing, I forgot what it was. What was our phi?
-2/pi.
-2. That was phi. Let me see, the original, it was a 4 there, right? So, yeah. Hold on a second. Losing track of what I'm doing here. -4. Okay, I think that's it. Yeah, so this is it. We're only looking at one piece of it. It's right here, goes down, comes back up, and ends here. That's what we're looking at right there, that piece. Okay. Is this good? Shall we try another? Let's do one that has tangent in it. How about that? So we haven't talked about this yet, right? How would we do a tangent? So the 2 here in front is not like an amplitude, okay? It doesn't, because tangent doesn't do what sine and cosine does, right? Just either this tangent we know goes like that, right? That's what tangent looks like. So had this been a -2, this is important, had that been a -2, it would have flipped it over. So had that been negative here, then it would go like that instead. It would be a flip over the x-axis, but it's not in this case. So we don't need to talk about the amplitude, but what about the period? Okay, so what about the period of this thing, t? Well, because it's tangent, we don't do 2 pi over this number, we do pi over 4. So we should have a period of pi over 4. And now we need to find kind of a start and a stop. But what we do is we take the argument and we don't set it equal to 0 and 2 pi. We set it equal to, well, what are the 2 important points on the tangent, on the basic tangent graph? What are the 2 important points? So on tangent, what were the two important places where we had the verticals?
Negative pi over 2 and pi over 2.
Negative pi over 2 and pi over 2. So that will be what we use. Negative pi over 2 and pi over 2 will be our special points that we use for tangent. And then we solve these equations. So I'm going to solve this. I got 4x. I'm going to add pi to both sides. So negative pi over 2 plus pi. And when I do that, get a common denominator, I should get just pi over 2. And then I divide by 4, and I get pi over 8. On the other equation, same thing. I add pi to both sides. And so I get 4x equals common denominator. So I get 3 pi over 2 this time. And divide by 4, I get 3 pi over 8. Any questions there? Okay, these are real easy to graph because once you have your 2 points, pi over 8, 3 pi over 8, you know that these are where your 2 verticals are. You also know that you have a middle point that you need to find. So you would do the same thing. You could add those up and find the middle. And if you do that, you should get 2 pi over 8, which is pi over 4. I'm not showing that work. And then it's a tangent. So all you have to do is this. And you're done.
So on these, we don't have to solve for everything.
That's right. You don't have the 5 points. All you really have here are the 2 endpoints and the middle point. Let's do the same problem.
You said that if it was -2, then it
Yeah,
would
so
be
that's been negative. Here's how the graph would change. If that number was a -2 instead, then the only difference would be that the graph looked like this.
okay.
It just flips it over the x-axis. Okay, let me take this, let me do a new one, but let's change it. Let's do, instead of tangent, let's do cotangent. Okay. So everything is the same in terms of the period. The period is still going to be pi over 4. The thing that changes is the start and the end, the start and the stop. The 2 equations we have here are 4x minus pi equals something, and then the other one is 4x minus pi equals something else. Now, for tangent, it's negative pi over 2 and pi over 2. For cotangent, the verticals happened at 0 and pi. So that's what we're going to use here, 0 and pi. So if I needed to summarize things, if you're going to find the start and stop for sine or cosine, it's 0 and 2 pi. And then like Anna Marie said, if you're doing the reciprocals like cosecant or secant, it's also 0 and 2 pi. If you're going to be doing tangent, it's negative pi over 2 and pi over 2. In cotangent, it's 0 and pi. And you just have to know that. Right now I go and solve. So add pi to both sides, I get 4x equals pi. Divide by 4, I get x equals pi over 4. Okay, here 4x equals 2 pi. And then x equals, divide both sides, we get pi over 2. So 2 pi over 4 would be pi over 2. So I go to draw my graph. Pi over 4, pi over 2. These are where my verticals are. I know that halfway is where I'm going to have my x-intercept, so I find the middle of those. So I go pi over 4, I add pi over 2, I divide by 2, so this should be, let me see, 4 pi, 5 pi over 4 over 2, so we should get 5 pi over 8 for the middle piece. That should be the center. And because it's cotangent, not tangent, it's going to go like this instead. A common mistake students make is that they say, oh, well, the cotangent is just the tangent one flipped over, right? Like we just did this one. And we said, oh, if you change that to a -2, it flips it over, right? To the green one. This green one is not the same as this function with cotangent, because where it starts and stops, see, it starts at pi over 4 and ends at pi over 2. Tangent with the negative in front starts at pi over 8 and ends at 3 pi over 8. So they don't have the same starting and ending points. Even though they look the same, they have a different shift. Okay, what do y'all think? It's all right?
Really quickly, could you repeat what the basic points for the starting and stopping were for
Yeah,
the
okay,
graphs?
so I'll write down. For the start and stop, okay, for sine, cosine, cosecant, and secant, for all those, you would do 0 and 2 pi. For tangent, it's negative pi over 2 and pi over 2. And for cotangent, it's 0 and pi. Now there's one more tricky piece, one more thing that can get us hung up, okay? So you all ready to look at it? It's the last kind of idea here that we have to be careful with. I've avoided this on purpose. Let's look at this one here. All right, so the -3 on this sine function means we have an amplitude of 3, but we're going to flip it over the x-axis, right? I mean, we know that it's going to be a reflection over. Now, this is the first time I've shown you a problem today where we have a negative in front. Do y'all see that? The negative in front of the x. So our omega is a negative number. And that's going to have an impact on things. All right, let's see how. All right, let's see how. So this is going to be a tricky thing. All right, so first of all, amplitude of this is the absolute value of -3, which is 3. I'm just going to remember that we're going to be flipped over the x-axis because it was a negative. All right, the period t is 2 pi over -2, right? That's weird. But a period is always going to be looked at as an absolute value. So we're going to say that the period of this is going to be pi. We'll put -pi, but we'll put an absolute value around it. So pi. The period is always a length. Okay, so I'm going to just put pi here. Now, phi here is pi over 2, right? And so the phase shift should be equal to phi, which is pi over 2, over omega, which is -2. And when you get that, what do you get? Should be like -pi over 4. Right, because you're just looking at the bottom as being a fraction, -2/1, then you're flipping it and multiplying. Let's look at the start and stop. So for the start, stop, I'm going to take -2x plus pi over 2 equals 0. And then I'm going to go -2x plus pi over 2 equals 2 pi. I'm using 0 and 2 pi because that's what we always use for sine. And now we're going to solve this for x. So I move the pi over 2 to the other side, it becomes negative, and then I divide by -2, I should get pi over 4. On the other one, I subtract pi over 2 on both sides. Yeah, I subtract pi over 2 on both sides. When I should subtract pi over 2, so if I do 2 pi and I take away pi over 2, I should get 3 pi over 2. I'm not going to show that. And then x will be equal to -3 pi over 4. And that's because when you take this number here and divide it by a negative number, you get a negative answer. Okay. Are there questions?
I'm a little confused on how you went from 2 pi to 3 pi over 2.
We should have, okay, so here at this point, I subtracted pi over 2 here, right?
Mhm.
Subtracted pi over 2 here, so that's this right here. Then I got a common denominator, 4 pi over 2 minus pi over 2. And now I do 4 pi, take away pi, would give me 3 pi over 2. That good?
Yeah,
Okay,
I just thought I would have gotten to a different answer. Sorry.
okay. Yeah, no, it's okay. I realized that all these little arithmetic things are stuff I've been doing for my whole life, you know, so it comes fast to me. But I do expect that you would write those down and kind of take your time through them. All right. We ready to graph? So this is where things are strange here, because I'm going to put our two start and stops. Pi over 4 is a positive number, so this is pi over 4. And then -3 pi over 4 is a negative number, and that's going to be further out here, like -3 pi over 4, right? And because this is a sine curve, we have to do a halfway point, and then halfway and halfway. So let's find this middle point first. Okay, let's find that middle one. That one we'll add those up. So -3 pi over 4. We'll add to it pi over 4, and we'll divide by 2. So if we add these up, we get -2 pi over 4 over 2. And that's the same as -pi over 2 over 2. And so you should get -pi over 4. So that's this, -pi over 4. Now my graph's a little bit off here because I just put these points here randomly, but can you all tell what the point is between these two? What should the point be between these two?
Wouldn't it be like -pi over 2? Or on the left side right there?
I'm saying between these 2 points right here, what's the point right in the middle?
0.
So like, let's just say this had -3 and 3. See, these are the same number, they're just opposite side. So -3 to 3, the number in the middle would be 0, wouldn't it? So I drew the little tick mark here, but actually it should be right here and it should be 0. That should be another, that's like the 3/4 mark. And I still have to find this one. Does that make sense, James, what I'm saying?
Oh, yes, sir. Yeah. Bro.
So let's find the halfway point between these two. So I'm going to go -3 pi over 4. And I'm going to add to it -pi over 4. And then I'm going to divide that by 2. So I get, let's see, this is -4 pi over 4 over 2, which is just -pi over 2. Because 4 over 4 cancels, you just get -pi and then divide by 2. So this should just be -pi over 2. All right, you ready for the tricky part? You ready for the tricky part? Okay. We know absolutely that for every sine function, the x-intercepts happen at the ends, right? At the ends. and in the middle. So I know for my graph, I have to have an x-intercept here, here, and here, right? My amplitude is supposed to be 3, and I'm supposed to flip over the x-axis. So here's 3. I'm just going to make this up. Here's -3. So you might be thinking to yourself this, right? Don't do this. Don't write this down. But you might be thinking, okay, here's an original sine function, right? But I'm supposed to flip it over the x-axis. So you may be thinking that your final graph's going to look like that, right? That may be what you're thinking. And it may turn out that way. I'm just saying this is not the way we need to think about this. And it's because we have that negative, oops. It's because we have this negative right here. This is always dangerous because negatives in front of x's do a reflection over the y-axis. Negatives in front, right there, do reflections over the x-axis, but negatives in front of x do a reflection over the y. So we haven't had this yet. So here's my advice to you. Here's how I would do this, all right? If I were you. All I would do is just try and figure out what's happening here, okay? So let's just figure out what's happening at 0. That means let's take 0 and plug it into the function. Let's see what happens. What happens if I plug 0 in here? Okay, so we go -2 times 0. -2 times 0 would be 0. And then sine of pi over 2. Now, what is sine of pi over 2? Think about your unit circle. Pi over 2, straight up. It's the point, what, 0, 1?
It's 1.
So it's 1, right? So this is really just -3 times 1, which is -3. Now, why did I do that? I did that because that forces me now to understand that this point is down here at -3. And if it's down here at -3, then that means over at -pi over 2, it must be up. And so it's going to look like this. Do you see the danger here? Had you drawn it, you know, if you draw this without the negative, you would have drawn this. And then you would have flipped it, but that would have been incorrect. And it's because the negative in front, it causes that issue. Do you all agree that that's tricky? Okay. I think it's probably worth it if we do one more. And I think what I'll do is I'll have you try and
Can
get
you
this
show
one.
the correct way to graph that last one?
Pardon me?
Did you show the correct way to graph the last
Yeah,
one?
this is it right here.
Oh, okay.
This is it. So what I did is I did like a test point. I plugged in 0. So I said to myself, look, I see a negative here, and negatives in front of x's always throw things off. So instead of doing my 3 points and then just doing like up, down, and then trying to flip it, I said, forget that. I'm going to abandon that method completely. What I'm going to do is get my 3 points, and then I'm just going to pick one of these points, plug it in, and then I know where one of those points is. So I know where the valley is. That means the peak has to be here. That makes sense, Maddie?
Yes.
Okay. I would like for you to take a minute or two, try and get this one set up in terms of, you know, figure out what the amplitude is. Does it, you know, flip? Figure out what the period is. Try and figure out the phase shift. Try and get your start and stop for this. Okay, so try and do amplitude, period, phase shift, start, stop. And I'm going to call on somebody in about, I don't know, I'll give you about 6 minutes. Okay, are we ready? Let's see here. How about Leslie? You there, Leslie?
Yes, I'm here, but I didn't do this problem. I had issues, and so I'm gonna have to rewatch this lesson because I'm lost.
That's fine. Okay. How about Angelique?
I'm here.
Good. Were you able to get somewhere with it?
Yeah, I wasn't by my notes at first, but I got up to T, or
Okay.
up to the period.
Okay. So what amplitude obviously is what?
3.
3. Okay. And then the period you got was
Negative pi.
negative pi, which we're just going to look at the absolute value. So it should have a length of pi. All right. Now, how about phase shift? Did you get that?
No, but that would be pi over 2 over 2.
Negative 2. Yeah. There you go.
Yeah.
So negative pi over 4. Okay, good. Now let's all do the start stop together. So we just do negative 2x plus pi over 2 equal to 0 because it's cosine, right? Negative 2x plus pi over 2 equal 2 pi because it's cosine, right? So we're doing 0 and 2 pi. And the first one, I just subtract 2 pi from both sides. I'm sorry, subtract pi over 2 from both sides, and then divide by negative 2, which gives me negative over negative is positive. You should get pi over 4. On the next one, you subtract pi over 2 on both sides. You should get 3 pi over 2. So very much like the last problem, right? And then divide through by negative 2, you should get negative 3 pi over 4. Is that what we had on the previous one?
Yes.
Yes, yeah, it was the same. Yeah, same arithmetic on that one. Okay, so now when we draw it, we have pi over 4 here. We have negative 3 pi over 4 here. And since it's just like the last one, right, we'll have the same important points. So we're going to have 0 here. We're going to have negative pi over 4 here. And the other one was negative pi over 2. Okay. That okay with everyone?
Yes, sir. I
Okay,
got
now,
confused. Well, not confused, but I don't know, I got kind of confused on the graphing because I ended up finding the cosine of pi over 2, which was
Okay.
0, and then I multiplied that by negative 3, which was 0. So I don't know.
yeah, okay, so I know what you're doing. So this, at this point, remember when we had sine, what we said to ourselves was, well, for every sine function, the x-intercepts are at the ends and in the middle, right? But for a cosine function, the x-intercepts are not at the ends in the middle. It's at the quarter marks, right? So for a cosine function, we should have zeros here, which is what you did. You plugged in negative pi over 2, and you got 0, which is correct. And if you plug in 0, you should also get 0. So instead of testing these points, we just need to test one of these other 3. So how about we just go with pi over 4? Let's plug pi over 4 into this and see what happens. Now this is going to be a little tricky. Negative 3 cosine of negative 2 times, I'm plugging in pi over 4, plus pi over 2. All right, let's figure out what all this is in here. What would this be multiplied together? What's negative 2 times pi all over 4?
Pi over 2, negative pi over 2.
Right? Negative pi over 2. Then we're going to add to it pi over 2. So what's negative pi over 2 plus pi over 2?
0.
0, okay, and that's negative 3 times cosine of 0. Now cosine of 0, just go to your unit circle, go to 0 degrees. So cosine is the x-coordinate, so shouldn't that be 1? Everyone, yes? And then negative 3 times 1 is negative 3. So what that's telling me is that when I'm here at, where's my, there it is. When I'm here at pi over 4, I'm down here at -3. And here's my positive amplitude, +3, right? So can y'all tell that from this right here, because this endpoint is down, that would mean that this endpoint also has to be down right here. And that means the middle point is the point that's up. You'll see how just having that one point allows you to find the rest of them without having to plug anything in, because it still has to look like a cosine function. So that means it's going to go like this, and like this, and like this, and like this. These are tricky. I understand that these can really be confusing. I guess if we're going to kind of summarize like how we would approach things is if we have something that looks like this or this, right? If we have these two, then if we see a positive omega, if it's a positive number, then just do it the way we were doing it. Do a start, stop, do your points, and just draw the way you would normally draw, right? But if these omegas are negative, you should always do a test point to figure out what's happening to be safe. Now, if you want, you can do a test point all the time on every single one you do. Just do the points you know. If it's sine, do the 3 points, two on the outside, 1 in the middle, and just test one of the other points. Or if it's cosine, you can do the 2 points at the quarter marks and then test a point. That's kind of the way that I like to do it, is just stay safe, put the points I know, pick a test point. Once I have that point, everything else just kind of falls into place. Questions, comments, Anna Marie?
On the last one that we did we flip it over the x-axis?
Did we?
Yeah, I know we flipped it over the y.
Well, okay, so that's what I'm saying is that when you have these, we know that this -3 means we're supposed to flip, right? But the problem is this one right here, when we flip over the y, it can actually have an impact of reflipping it over the x. Maybe I can do it this way. So if you take a sine curve, right? Take a sine function. If I flip that over the y-axis, right? If I flip it over the y-axis, then it would look like this now, right? But if I flip it over to the x-axis now, what's going to happen? Want to go back to the original? Do you see that? Like this would come up, this would come up, this would come up, this would go down, this would go down. So it's when we have these double flips that it's hard for us to understand what actually happens, because you could have a double flip, but then you also have a shifting. So that's why I think this method is the safest. You don't really even care too much. I mean, you do want to know the amplitude. That you do need, because you need to be able to put 3 and -3. But as far as the period phase shift stuff, that really doesn't come into play when we graph it. All that matters is we get our start and stop, we get those quarter marks, we put the points in, and then pick a test point. Let's do one more. Let's do one more, because I feel like this can be somewhat well, there's no more here that have a negative in both, but I'll just make one up. How about I just make one up? Okay, let's do this one. Yeah, because we don't have enough time to get into the next section. Let's say we do y equals, let's go -2. You want to do a sine or a cosine? Let's do cosine. Let's do cosine. Or do y'all want to do a secant? Let's do a secant. How about that? Secant. Let's go -3x plus pi. Let's do that. I'm not going to do, well, do y'all want to do a vertical shift? We can do a vertical shift. Let's do one thing. Let's do -1. Okay, so this is like the worst problem I can come up with then. I've got so much shit happening here. that it's going to be hard to keep track of, okay? So because I know I've got these negatives everywhere, the main thing I'm going to be concerned about right now is the amplitude. The amplitude's 2, okay? I also know that this thing is going to go down 1, isn't it? And I'm going to graph the cosine function. Why am I graphing cosine? Because secant is 1 over cosine. So I'm going to graph the cosine, treat this like a cosine right now. So I'm going to find the start stop. And to do that, I take the argument, set it to 0. I take the argument and set it to 2 pi. Okay, here we go. So on the first one, I move pi over. And then I divide by -3, I get pi over 3. On the other one, I subtract pi. So 2 pi take away pi gives you pi. And then I divide by -3, I get x is negative pi over 3. Go good with that? Here comes my picture. Well, at least the beginning of my picture, all right? So I'm going to start at pi over 3 and end at negative pi over 3. So I'm going to put pi over 3 here, put negative pi over 3 here. Okay, so the good news here is that halfway in between is 0. I know that. And then these two I could find, I'll leave that to you. This would be pi over 6. This would be negative pi over 6. Okay, any questions? Do I need to slow down? Am I okay?
You're good.
Doing good.
Good. Okay, so I'm about to graph a cosine function. And so I know for cosine functions, my x-intercepts are at the quarter mark and at the 3/4 mark. So what that tells me is, oh, and what was the amplitude? Amplitude was 2. So here's 2.
So we're gonna have we gotta shift it down 1, so we're gonna start at 1 and end at -3.
I'll do that in a second. I'll do that almost, it won't be my last step, but it'll be close to my last step, right? I know I'm supposed to go to -2, so don't write this down. This is one thing. It could look like this. Okay, it could look like that, or it could look like this. And because I've got like these double flips and stuff, I'm not even going to worry myself about with that. What I'm going to do is I'm going to pick a test point. Let me leave those back up here. Okay, so I'm going to pick a test point. I'm going to test 0. Oh, I'm going to erase 0. I'm going to test 0. I'm going to plug 0 into the original function and see what happens. Okay, so when I plug 0 into the original function, and you know what? I want to be looking at cosine right now. So I'm actually looking at not the secant, but and then the +1, I'll put it there. So does everyone see I've converted the secant to cosine? So I can do this. Plug 0 in now, and let's see what happens. When I plug 0 in here, I just get pi, and then +1. And what is cosine of pi? Go to your unit circle. Pi is here. What's cosine of pi?
Wait, +1? Wouldn't it be -1?
Where?
At the -2
Oh,
cosine.
for cosine of pi?
You have +1.
Are you saying
after
cosine of
that.
pi is -1?
In the
Yes, but
equation?
cosine of pi is -1, yes?
Yes.
Yes, so this is -1. So we have -2 times -1 and then +1. So this +1 will come at the very end.
But why
Not
is
yet,
it
right?
+1 instead of -1? Because in the original
Did I
equation.
put, I put a -1 up there. I'm sorry. I just overlooked that. Sorry, everyone. That's a -1. Oops. -1, -1, -1, right? So think about this. When we do this right here, what do we get? -2 times -1.
2.
We get a 2, don't we? This is a 2. Now that's before the shift, right? This -1 is going to shift it down 1. So this is our shift down, but Do you all see that by plugging in 0, it's spitting out a +2, which means it should look like this orange one, not the blue one. That's the key here. It should look like the orange, not the blue, because of this test point at 0. So let me get rid of the blue one. That's what we got so far. Now I need to move the whole thing down 1. The whole graph needs to come down 1. So every point, this point, this point, this point, this point, this point, they all need to go down 1. So if I move that down 1, we're here now. This one down 1, we're here. This one down 1, we're here. This one down 1, we're here. And this one down 1, we're here. So we're now in -3. I'll draw this in a different color. Okay with that? I'm going to get rid of the orange one. There's where we are. Now, do you remember where the vertical asymptotes were? They were here and here, right? That's where they were before we moved it down. And remember, we're drawing the secant function, right? We're not drawing the cosine function. So my final picture has to look like this. From this peak up, like that. And then over here, I can go from this bottom valley point this way and this point this way. The black picture is our picture. I'm out of time. So I would say, do your best on the homework. I'll do the video for the homework when I get a chance, hopefully today, and see how it goes. All right, everyone, got to call it a day because we're out of time. So y'all have a good one. And I will see you, Wednesday, right?